I'm a marine ornithologist with Scottish Natural Heritage and also a PhD student at the University of Glasgow. And this is a piece of work that I've been doing in collaboration with a number of other people, including Chris Thaxter and Angus Cook from the BTO, Bob Finesse from Macarthur Green and the University of Glasgow, Francis Daunt from the Centre of Ecology and Hydrology, and Liz Marsden from ERI. And what we've been looking at is reviewing bird diving behaviour to see how this can be used within collision risk modelling and assessing collision risk with tidal turbines. So what I'm going to do today is start off by giving you a little bit of background as to why we've undertaken the review, then go through the scope and methods that we've used before giving some examples of a data-rich, data-moderate and data-poor species, and then looking at what the conclusions we can draw from these and implications for assessing collision risk. So, unless you've been asleep for the past couple of days, we know that there's potential for birds foraging in areas where tidal turbines are to collide with them. They could possibly be killed from this. There's also the possibility they could be injured, while others may avoid them. Within the UK, we do have a legal requirement to assess them through an environmental impact assessment, and in relation to Natura sites such as special protection areas, through a habitats regulation appraisal. But how do we actually do that? Well, we can look to the approaches that have been taken both in terrestrial and offshore wind farms. So Bill Band actually has developed a collision risk model which quantifies the birds flying through rotor swept areas. But can we use that approach underwater? Well, there are actually a number of different models that are being developed to do this underwater. So Bill Band's been working on an adaptation of the terrestrial and offshore collision risk model, putting it underwater. There's the folk at Sam, Bob Batty's been looking at the developing the SRSL encounter rate model. And there's also the exposure time model, which Murray Grant has a poster on downstairs. They're all either within the audience or presenting things certainly at the workshop tomorrow, so I'm not going to go into any more detail than that. But it is worth considering what actually goes into these models, and there are some similarities between them. We need to know information about the turbine, the geometry of the different turbines, and we want to know information about how birds are using the area, so we can try and calculate a probability of encountering a turbine. I'm not going to go very much into the turbine designs, but it is just worth pointing out that unlike offshore wind farms, tidal turbines come in a variety of different sizes and also positions within the water column, and this needs to be taken account of in collision risk modelling, but also that some designs may actually present more of an entrapment or a collision risk than others. Moving on to bird foraging and diving behaviour, what kind of things do we need to know in order to actually to calculate a likely exposure to a tidal turbine? Well, we want to know information about the depths that they're diving to and the proportion of time that they're spending at these vulnerable depths in the rotor swept area. So we need information on dive depth, the distribution of time spent at these different depths, and the proportion of benthic dives a species might make, and also information on the speed that they're travelling, both when they're ascending up and descending down, and also horizontal speeds at the sort of depth of sort of further down in the water column. We want to know information about how much time they spend underwater, so the dive duration, also the pause duration, and the number of dives they might take in a diving bout, and also information on the bout duration. Because there is different information available on different parameters, we might sometimes need to use alternative methods to calculate diving frequency. So for this, information on the number of dives per trip, trip duration, and the proportion of time they spend at foraging location are all quite useful, as well as the number of trips an individual might make per day. But obviously, as any good scientist or modeller knows, the accuracy of a model is dependent on the information that goes into it. So what do we know about bird foraging and diving behaviour at the moment? Well, we've decided to undertake a review of 18 different diving parameters for 22 species that are located, marine bird species in UK waters. And this comprises divers, grebes, shearwaters, gannet, cormorants, sea ducks and auks. And the way we scoped the species in was to consider whether they dived within or beyond the depths that we know that tidal turbines are likely to occupy. So that was 3 to 80 metres. So what did we do? We looked at the maximum, the mean maximum, and global means for these different parameters. The global mean is the mean value for each colony averaged across all colonies. Quite often studies will quote different parameters. They'll maybe present a value for chick rearing and incubation, or males and females. So we average these values. We've also got multiple studies sometimes being conducted at the same colonies, or multiple years being reported for individual studies. In either case, to avoid any undue bias, we averaged across these values so that colonies that are better studied aren't there isn't a bias towards them. We then decided to prioritise studies where direct methods are used. So this is studies that particularly use tagging information, so TDRs and accelerometers. And we wanted to provide a measure of confidence in each of the parameters that we have for all the different species. So for this we used an approach that was developed by Thaxter et al. For seabird foraging ranges. So where we've got species that there's 5 or more direct studies that have measured the value, we've got a high degree of confidence. 2 to 5 direct studies is moderate. If there's only 1 direct study or indirect measures, a number of indirect measures, we've got a low degree of confidence. If it's just survey-based estimates, we're saying that we're uncertain about it. And if it's only a few survey data or it's speculative data, then we've got a poor degree of confidence. So looking at an example of a data-rich species, the European shag is a particularly well-studied species. There's study sites such as the Isle of May where we've got loads of really good information, and we know that they cope really quite well with tags, all sorts of different tags, including bird-borne cameras. So they're very easy to study, and we've also got lots of information about the birds actually at the colony as well. So just to have a quick look, you can see sort of as you go down, there is a range of it varies from sort of 3 to 1 location, or 5 to 1 locations, and there's actually a huge range of the number of studies that have actually reported. But you can see some parameters have had far fewer studies reporting values than others. And we've got a range of high to moderate confidence in most of these values. It's also worth pointing out that there isn't necessarily a logical link between the dive depth and dive duration. And this is because more studies have actually reported dive duration and dive depth. And so it basically means that the global mean for the dive duration is lower than you'd expect given the global mean for the dive depth. Then moving on to a data moderate or poor species, we've got the black guillemot or toasty. Now they're actually quite sensitive to tagging, and so there haven't really been that many direct studies, but there's work by Liz Masden up at Stroma and also the RSPB in Orkney means that we are starting to get a little bit more information, particularly with the advances of remote downloading technology. It's worth noting, sort of comparing some of the results with shags. You've got the dive duration for black guillemot is actually considerably longer. It's 35 seconds longer than the shag dive time. But the pause duration is quite similar. But interestingly, the number of bouts is actually fewer. So toasties are taking longer dives but less frequent dives within a bout. Moving on to a data poor species, we've got the red-throated diver. Now they're an incredibly sensitive species that we've really struggled to put tags on. They don't tend to cope very well with it. And so most of this works through observation. You can see there's, again, a number of parameters that we haven't got data for, and the ones that we do, we've got quite poor confidence within them. But what is quite interesting is that they're diving, the mean depth is actually quite a lot shallower than shags. The dive duration is it's shorter than both shag and black guillemot. And also the forage trip duration is quite a lot shorter, but the number of trips that they make compared with shags is actually quite higher. So you can see between these 3 species, they've actually all got very different diving and foraging behaviour. So to summarise, our current knowledge is very variable across parameters and between species. Presentation of parameters within studies is not always comparable. Some parameters are reported quite frequently, but depending on what the ecological questions are, not all of them have necessarily been reported. And an example of this is horizontal speed. You quite often get ascent and descent speeds recorded, but accelerometers and TDRs don't tend to readily record the horizontal speed. So this is an area which we think is actually going to be really quite important in calculating collision risk. And also, some species are more difficult to study. However, improvements in technology such as remote downloading does mean that species such as black guillemot have the potential to sort of get more information from future studies. So, in conclusion, well-studied species such as shag, gannet, leaping ahead there. So in conclusion, some of the more vulnerable species are difficult to study and our confidence in these is lower. And there's a need to measure more poorly understood parameters, for example, horizontal speed. Now this is the point I was getting to. Well-studied species such as shag, gannet, guillemot will provide a useful opportunity for studying the effects of renewables. And this is particularly because we've obviously got quite a lot of existing data, but also they're really quite easy to study at colonies, so we can kind of compare and maybe move up to looking at population level effects. But I guess the big unknown, and this has come across from the different workshops and other talks, is that we don't know how these species are going to interact. And really trying to quantify avoidance within the models is going to be one of our biggest challenges. And it's just to sort of really highlight that robust post-construction monitoring is really important to help inform future assessments. And that's me.
Thanks, Alex. We have time for 2 questions.
You mentioned for your review, highlighted horizontal speed and buoyant behavior. What would you consider high priority or minimum set to actually do a reasonable assessment?
Sorry, I missed the. Can you repeat that? Sorry.
In addition to horizontal speed and avoidance behaviors, what among those reviewed parameters do you deem essential to make a reasonable study or reasonable assessment of risk?
I think it's sort of. I'm just trying to think really. In terms of the different parameters, things like dive depth and duration tend to be quite well studied, but some of the ones that are sort of lower down within them, I'm just trying to have a look. Some of the other ones, sort of like numbers of trips that they're making and trying to get at the turnover within the site. I think that's something that's not really been addressed very much at the moment. And certainly, things like the dive depth tends to be slightly more covered than some of the others, but it's depended on what the ecological questions necessarily been asked, because a lot of the studies that have reported these values have been trying to, I guess, get at other questions rather than what we've been looking at in terms of marine renewables.
I think we'll leave it there in the interest of time, but please do